I'd like to introduce my colleague, Dr. Jessica London from IDM, who's a principal scientist. Jessica has a diverse set of professional experiences in AI, including Microsoft Research, Salesforce, and some interesting entrepreneurial activities that you should ask Jessica about at lunch or in our coffee breaks. I've heard Jessica say also, and I really love when you say this, that she's been publishing in the NLP space quite a bit before the release and kind of advertisement of GPT-4. So she's an incredible resource, and I'm excited to see her presentation. So thanks, Jessica.
Yeah, thank you. Can you guys hear? Yeah, great. So I'm Jessica, and thank you. So next year actually will be 20 years that I've been doing what is called AI now. And it was actually 10 years ago that I started working with language models. And it's something that I love. There's no more interesting time than right now to be in this space. And I'm looking forward to sharing with you some work that I joined when I joined here 4 months ago on building out a benchmark data set. And what I'm going to speak today about is quality and how that relates, how data quality relates to building capable large language models. And I'm just going to mention low resource languages. This is a term from the literature, just meaning languages that have less text, less speech that's published to train models. Oops, one more. Okay, so I'm going to speak about this AI workflow, and I'm going to work my way backwards. So we'll start with deployment, and by that I mean applications. And then we'll talk about how data quality inserts itself at every single point along this workflow. So the first thing I did when joining here was build a chatbot. So I stood up code for an HIV, a chatbot for men living with HIV in South Africa. And you're seeing the script play out here. One thing that you might think of when you look at this demo is how accurate are these models, these large language models, in English for sure, but also when we stand this up in other languages. So this particular demo is extensible to any of the 243 languages that Google Translate supports. But again, how accurate is this information? This is obviously important to us when we think about presenting health information for people. So we're going to take one step back in our workflow development and think about evaluation. So how do you test how accurate large language models are in all of these languages? And the answer might be intuitive. I hope so. We actually have the large language models take tests, like a standardized test, just like you would test a student's knowledge in a particular domain. And here is just one of several benchmarks that we built out, and it's a question and answer data set. So you can see that there's a particular question here where the large language model needs to respond with what we fill in the blank with. So in this case, there's 2 answers. Some of our other benchmarks, there's 4 answers. But you can see how from responses like this, from our large language model, we can then calculate what is the accuracy of these language models in all of these different languages. So it might be a bit small, but hopefully you can see that there are about a dozen large language models here on the left, varying sizes in terms of numbers of parameters. And at the bottom here are different languages. And so benchmarks like this help us understand how well our large language model is doing across languages. And since we published this work, or submitted it rather, I was able to run another handful of models. Those are outlined in the rectangle here. And what's interesting is a few things. One is you can see that Llama 3.1, so this was released in July, that it outperforms its equivalent of Llama 3, that was the predecessor. So this is, again, intuitive. But one thing that's quite interesting is looking at much smaller models. And to me, this is one of the most interesting stories right now that's happening, is that we have models like Phi-3. So Llama was put out by Meta, Phi-3 was put out by Microsoft. This is actually a model with 3.8 billion parameters, and Llama 3.1 here is 70 billion. So to see such a small model competing, just for this particular benchmark, it might be very different, and it is across different benchmarks, but it's a really great story that you can do so much when you have quality data. And to me, this is something that isn't necessarily in the news and the headlines, but it's so critical to how we build capable models, useful models for using every day. So I'm going to switch and start talking about data-centric AI. This is a term that I did not make up. What this means is that we hold constant our model here, and we really think about how improving the data collection, data analysis, how we can lift the overall system performance of our model. And this is counter to thinking about model-centric development, where instead we think about this component here, the model training and the model tuning. And it's interesting because it's the model-centric AI that is what we publish. And it's really what we think about, right? When you think about the number of parameters, you can think about all sorts of details about attention query heads and very, very specific things about model architecture. And that's what's published. And that perhaps is what we think of most often when we're interacting with GPT online. But it's actually this part about the data-centric workflow that this is where we spend our time when we're building products. And this, in fact, is where a lot of time is spent by these large foundation models as well. So we'll dig into this a little bit further. Here's a few quotes from technical reports that have been put out recently. So Llama 3.1 we mentioned, using pre-processing and curation pipelines for data is a critical component to how they built out this model. Qwen 2, this is a model put out by Alibaba in July. Again, using heuristics and ways to filter data for quality is critical to their model. And they also use Qwen models themselves to filter this data. So you can actually see that there's quite a lot of overlap during this entire workflow of thinking about data, thinking about models, alternating back and forth. And then finally, GPT-4, what was notable about this particular report was the lack of mention of their data set construction. And the reason for this is that data is so much part of their core IP that they don't actually publish what their data-centric workflow is. And I think that that's a really critical part of this. When we think about the quality of models, it really, a big part of that is in this data curation step. Okay, another piece of evidence for why foundation models think critically about data-centric AI. OpenAI just recently published this MMLU dataset. So again, a question and answer dataset to measure accuracy of these models. They published this in 14 languages. And again, something that isn't really spoken about very often, but is so critical, is the role of benchmarks in driving innovation. And what I'm so excited about for this particular release of data is the ability to improve performance of these models across an increasingly large number of languages. So switching to some of our work, we built out a question and answer benchmark, 5 benchmarks actually, in 11 low resource languages. So we're going to switch on our continuum of the AI-centric workflow and think about, or the data-centric workflow, and think about the collection and labeling part of this process. And this is something that isn't frequently spoken about, but is so critical, again, to coming up with quality models. So what we did is take benchmark data sets that are in English and translate these into other languages. So we have a source language, that's English, and then target languages. And we have our first annotator come up with a translation. The second annotator either accepts that translation as perfect or they update it. And then there are 4 annotators that give a quality label or an appropriateness label. And examples of what these labels look like are given here. So these are categorical labels. And from this, we can move into I'll give an example first. An example of translating into Zulu, and this is from our data set. We have some text in English. We can translate that by the first translator. The second translator updates this particular record, and then the quality annotators give a label and the appropriateness annotators give a label. And you'll see that they don't always agree. And this is expected, and we actually want this. And it could be perhaps that the content of this particular record is in some way not appropriate to one of our annotators, and that's definitely something that we want to think about. And something a little bit above what others do often with labeling data is we did this appropriateness annotation because it is so critical when we're working across languages to be sensitive to cultural differences. So next, I'm going to mention how we look at data analysis and pre-processing. You saw that we had quality labels, we had appropriateness labels, but what if we model, if we predict what those labels are, can we learn more about our data set? And this is the sort of steps that we take when building out data sets, is thinking back and forth of, can we learn more about our data set? Is there a way to improve it as we're doing annotations? And again, continuously improve. So here, what I did was build out a random forest, so a prediction model for the quality. And what you're looking at are the feature importances from that model. And you'll see that the top importances have to do with what language it is. So if we are in these particular languages at the top here, then we're going to have a more quality data set. So that probably boils down to our particular annotator labels. Then conversely, if our initial translator received a warning that their translation was too similar to machine translation, then that is adversely related to our quality. And I didn't go into all the details, but we do actually provide warnings to our translators to help nudge them toward a better quality translation. So there's quite a lot that goes into this process. Then second, if we predict the appropriateness of the label, then we can see again that there's certain languages that are more likely to be correlated with good appropriateness. And then conversely, you can see that if there are warnings, in this case, presented to the second translator, then those are less likely to be appropriate. And finally, if we combine these, this is the last experiment I did with this particular work, is predict the, both annotators reported that it's appropriate and that they were also given this quality feature. So what we wanted to see here is to what extent is quality and appropriateness related. And it turns out that quality is in fact the largest predictor of appropriateness for our data. So it's great to have human annotations, but one thing that I hope everyone takes away from this work is that we can use these large language models to supplement other data collection efforts. So we can actually use the large language models as a judge, to judge, in this case, quality. We could do the same thing with appropriateness. There's going to be other aspects of any data set that we work with where we can utilize these large language models and get a relatively cheap and fast label. And what we did was look at the quality score now. So this is a score of 1 to 10. of what quality is perceived by the ChatGPT model. And from here, we're switching into this model-centric AI. So before, we were really looking at how can we change the data and increase our evaluation. And with the model-centric workflow, we're switching paradigms and thinking, how can we change the model itself and improve the overall performance? And again, we're switching back and forth. And this is part of the natural workflow of building out AI products. So the first result here is looking at the out-of-the-box data quality. So what's the accuracy of these models out of the box, no fine-tuning. And then we can look at fine-tuning the lower third and the upper third of data as deemed by this ChatGPT model. And you'll see that there is an accuracy lift for this Amharic language between the low and the high quality models. In English, we actually don't see the same behavior. And this particular model is fine-tuned on the Llama 70B data set or model. And the thing is that Llama and this particular version was entirely trained on English. So it's going to be less sensitive to splits in quality. And the final figure I'll share here is looking at both quality and quantity, because we know these things both influence the overall capability of our system. So there is here on our legend, we have low and high quality data for English and our 11 African languages. And you'll see different quartile splits of our data. So there's 0 data with no fine tuning. If we fine tune on 25, 50, 75, 100% of our data samples, so different quantities, right? And you'll see with the different colored boxes, we're looking at different quality splits. And again, you see that there's this accuracy improvement with both quantity and quality of data. So these things are all intuitive, but they're extremely important when we think about releasing products like the first one I showed, the demo of chat experiences for people for health-related topics. It's really important to understand for every model that we might release, what are the implications for the amount of data we include and the quality of that data, and how do they measure up on these benchmarks? So summary slide here, we built out this we built out this benchmark data set, and we talked about how this AI workflow comes together and how data quality is important for every single step. We talked about the data-centric way of thinking about building out AI products and the importance of that. I think this is the sort of less told story when we read headlines in the news is, again, this importance of data quality, but it's certainly one that we spend a lot of time thinking about. So I included my email here, and I'm happy to correspond with anyone after this talk. Thank you.
Wow, the room filled up. I didn't see everybody come in. Fantastic. Well, thank you so much. Wonderful. We have time for a couple of questions. We might stay by the mic so that the online folks can hear. Do we have any questions? All right, we got 2 in the back. Josh, I saw your hand go up first. Oh, Amanda, you got it. Great, thank you.
This is a really interesting talk, Jessica. Thank you. Could you go back one slide? It was interesting to me that the scores seem to plateau so quickly. You know, even just 25% of the data gives you most of the improvement. How do you understand that, and what do you think the implications are?
Yeah, thank you for asking. Something that I forgot to mention about this particular result is that we are doing a lot with not very much data. So in this case, it's 66 samples. So I would take this as indicative that quality and quantity matter. However, I would want to do this experiment with a lot more data to say something more conclusive. It's always hard, like when you're comparing two different variables that influence your final outcome of which one's more important.
Thank you. Do we have any questions in the chat? I do not see any questions in the chat. We have a mic over here, and then we'll come here.
So I'm curious with all these different languages that you tested, if you looked at dialect at all, and if, maybe if annotators had very contentious disagreement on whether something was quality or appropriate, if that had anything to do with dialect. So for example, like Arabic spoken by, an Iraqi Arabic speaker might sound nothing like Egyptian Arabic, and those two people might say, well, this is not quality or appropriate. And how did you address that then when moving to like ChatGPT scores?
Yeah, that's a great point. And Arabic is such a good example. Dialect is so important to doing these annotations when we publish data sets. It isn't something that we explored in this particular data set, but we have other data sets that we're building out where we do note the dialect of the speaker, particularly for speech data sets as well, because the actual pronunciation can vary too. So that's a really good point.
So thank you. I have two basic questions. One is, how are you judging the quality of the data? Is that by a person or by a machine? And then the second one is are you translating and then using the model in English, or are you running the model on each of the languages?
Yeah, thank you for bringing that up, because it definitely could be clarified further. The quality translator is the quality of the translation is done by a human annotator in our benchmark. And so we give these annotators explanations, instructions for how to do this annotation. I also presented results here of using the large language model to do the annotation separately. So two different ways to get at the same idea. And then you had one other point, and it escaped me. Yes, good point. Okay, so again, I switched back and forth. At the very beginning, I shared a demo where we do the translation from the source language into English, and then we pass that to a model that comes up with a response first in English and then translates it back to the local language. So if you speak to our HIV chatbot in Zulu, for example, then it will respond in Zulu. But those are reasons of engineering that we made that choice, that design choice. For this particular study, we were passing the original language to the large language model to see what the performance is, because that's what we want to test ultimately. Is we don't want to have to do this translation step. We'd prefer to just pass the source language directly to our large language model. Yeah, thank you.
Great. Let's thank Jessica one more time.